Uh, Hello, this is the last presentation of the day. uh, it's a great honor to be here at the Spark Summit. I'm really enjoying this event. Um, it is full of interesting technology and people and good experiences. Today, I'm also here to share my experience about how Spark has helped me to solve difficult problems. First, let me introduce myself. My name is Jungryong Lee. I'm an IT manager of SK Telecom, which is the largest wireless communications provider in South Korea. I have worked on some big data projects using Apache Huddle and instant data processing engine. Now I explain my experience in the following order. First, I explain our background, which includes data size for processing and the size of systems and so on. Then I introduce two projects in short and go in more detail about each of them. Okay, our background. We are aggregating a huge amount of data every day. For example, it is an average of 40 terabytes per day. It will amount on an overall data size of 15 petabytes by the end of this year. Due to huge volume, we are very interested in Apache Huddle project for processing large-scale data. We have about 10 Huddle clusters which are various in size. The largest one has more than 500 nodes and a total of over 900 nodes altogether. We also have experience with using various commercial DBMS. So I introduced two projects using Spark. One is high-speed data processing. It is the replacement of MPP DBMS. The other is instant data processing engine. Instant data processing. It is the replacement of daily high-batch job. Now let me introduce them in more detail. I introduced the first project in more detail. In this project, we have generated about 500 statistical reports today, and we support our user-defined function, user-defined queries. We have been providing these functions through commercial MPP DBMS. This was our previous approach. As you can see, we aggregate raw data to Hadoop, then we execute simple ETL job using Manus framework. We also then we load this processed data to MPP DBMS using its connector. We also create math data for web client users. Most complex ETL jobs are done by MPP DBMS. At that time, the size of the data moved was about 100 gigabytes per day. This approach seemed to be working good. However, as time went on, the data was growing and we had some issues. At first, we had too much data to load MPP DBMS. It was growing at a rate of about 600 gigabytes per day. So loading data was no longer an easy task. And the more data there is in commercial MPP DBMS, the more expensive the license fee for MPP DBMS is. So we decided to integrate these two layers into Hadoop. In other words, we decided to replace MPP DBMS with Hadoop. We needed two main functions to replace MPP DBMS. We needed high throughput for large data processing and low latency for querying a small data set. We especially focused on low latency query because we had researched another Apache project, Tajo, for high throughput. Do you know Tajo? If you know the Tajo, please raise your hand. No. I give you the t-shirts after finishing presentation. Okay. This is our system requirements for low latency ad hoc query system. Except for low latency ad hoc query, we also needed the following functions. These features mean that we have to implement something like RDBMS for OLTP. We decided to use Shark. I think Shark can replace RDBMS for read-only data set. It has a low latency for ad hoc query with caching tables and low latency scheduler. In our case, there is not much benefit from caching tables because our data set is small and queries need many stages. This is an example of our query. As you can see, our query has too many stages. One query needs about 10 or 11 stages. Okay. This is our simple overall architecture for Shark on Spark. It is a very general architecture for Shark JDBC server. Then we start testing the queries. At first, only 8 queries could be run. So we modified some bugs, implemented some user-defined functions, and improved some queries. Finally, we were able to run a total of 524 queries. Then we needed to improve performance. Overall performance of Shark is very good. We can complete most queries in 2 seconds, but some queries don't meet our performance goal. We could improve the performance by controlling Hive completion parameters, but some queries still don't meet our requirements, and we found some queries have to finish in 0.3 seconds. With my experience, it is very difficult to complete query in sub-second with Shark cluster. So we are caching the query result now. This is an example of performance improvement. I explain how I cached the query result. It is mainly used for querying small data set that doesn't change over time. As you know, this is a simple logic for Shark server for JDBC query request. When query request is submitted, Shark operates SQL operation, fetch operation, and close operation in the order. It takes some time to complete query, even if it was very small data set, because it has access to HDFS. After understanding this logic, we removed the delete result logic from the close operation. Then we created cache manager, which remembers the location of result data. After we modified some additional codes for managing cache, we can cache the query result. We can reduce the query time with a simple understanding of Shark and Hive. Of course, most of queries complete in 0.3 seconds with caching. From this, the important thing is that we can easily understand the architecture of Shark and Hive because they are open source. With some modification, we can easily make caching of query result function like RDBMS. Next, I'll introduce another project for in-stream data processing. This project is a replacement of daily Hive batch job. The goal of this project is to reduce the interval of batch from 1 hour to 5 seconds. This application is very simple. The goal of this application is to get the results of the most used search keywords and applications. But there are two issues with this project. One is the size of data, which is about 1.5 to 2 terabytes per hour. In other words, it means that I have to process 530 megabytes data per second and more than 1 million records. Another issue is that we don't have time to implement this system because it must be done within 1 month. It is very short time for me to complete the project. So we decided to use Spark streaming. There are two merits with Spark streaming. One is that we can use our knowledge about Spark. As you know, this stream is very similar to RDD. Thanks to this feature of Spark streaming, we can easily change batch application to instant data processing application. Another one is the Spark and Spark streaming support local environment. So we can easily test our application code with our laptop. This is overall implementation process. It takes only 1 week to fully complete this process. This is overall data processing architecture. We made a very simple Spark streaming application. It creates and aggregates multiple receivers. Then it filters and summarizes data generated from the receivers. Finally, we save the result data to Elasticsearch. The Spark streaming application code is just 84 lines. An additional task that we have to do is to implement another simple data collector. Besides that, we had implemented all of the code in the Spark streaming application. Spark streaming has very good performance. As you can see, it could process more than 1 million records per second with 20 nodes. It is about 3 times faster than other instant processing engine. From this project, we can learn the following. We are able to implement both OLTP style system and instant data processing system with Spark and Shard. This is a very fantastic platform for processing real time, but we had to solve many problems during the time of implementing. These include compiling source, deploying application, and resolving some bugs. Whenever an issue happens, I always ask open source community. Spark community is very active, so I can get all the information I need from the community. Then, what does Spark get from me? Technically, the participation of the company makes the open source more robust and makes them focus on practical problems. With Spark, I can test in real-working clusters, mainly focusing on OLTP-style system and instant data processing with existing IT systems. I also find bugs and additional functional requirements too. I think an outstanding point of Spark is that it is genuinely open. Anybody can do whatever they want with it. Thanks for listening. Do you have any question?
Great. Yeah, so let's just give one more round of applause to the speaker. Thanks very much.